All right, welcome to factoring a GCF. So just again to reiterate, factoring is the inverse of FOILing. So like you FOIL, you multiply, factoring, you're dividing. So we want to try and get back to our original kind of statement. So here's our first example, 3x squared plus 15x plus 18. Now this one's a little bit tougher than station 1 because I have a number in front of a. I notice I say just a little bit tougher because there's really not much you have to worry about because you can look at all these terms and see that they all have something in common, 3. So I would start this by, and I'd start every factoring problem looking for this, taking out the GCF, the greatest common factor. So when I take a 3 out of everything, this is what I end up with. To factor to this, I need 2 parentheses. X times x will give me x squared. My factors of 6 are 6 and 1, 2 and 3. 2 and 3 multiply to be 6 and add to be 5. So those are the ones I'll use. And I would end up with a positive. So there's my answer. Notice I brought that 3 all the way down. Not everything will factor out after you take a GCF, but it is always helpful to look for a GCF. Our second example, 2a cubed x squared y squared. Wow, that's a lot. But it's not going to be bad because there's a big GCF here. Okay, so I'm looking for what's in common in all of these. They're all divisible by 2. They all have an a cubed in them. They all have an x squared in them. And do they have a y in common? Nope. So there's my GCF. So if I take 2a cubed x squared out of the first term, I only have y squared left. If I take 2a cubed x squared out of the second one, the 8 becomes a 4, and I just have the y left in my variables. And finally, if I take a 2 out of the 10, I have 5. The a cubed and x squared come out, so that's what I'm left with. Now I need to see if I can factor. So I know I'm going to have a y and a y to get y squared. My factors of 5 are 1 and 5. I need them to subtract to become negative 4, so I'm going to do a negative 5 and a positive 1. There we go. Good luck.